Alright, so in this video I wanted to talk about the coding implementation of bidirectional RNN with attention. And in the last few videos I talked about sequence-to-sequence models where we pick up the use case of machine translation, where we were trying to do like English to Korean translation, and we have seen the code implementation along with the concept in Pytorch, and we have so far we have used the sequence to sequence model without attention. So let's get started. So before moving into the code, the one thing which I wanted to discuss was like teacher forcing, and the teacher forcing concept we will use in this coding session. So let's first understand what is this teacher forcing. So if you remember, like in case of sequence to sequence model, we have an encoder and decoder architecture, and we pass our input sequences in the encoder side, and we get the corresponding translated version of those sequences at the decoder side, right? And during the training step, what happens is you can either pass your each of the decoder outputs, like this y1 can be passed as an input for the next time step, right? So if this is my t0, this is my t1, and this is my t2, so this y1 can be used as a input for the next time step, that is t1, right? The other way around is, as you are training the model, right, so you know the actual values of this translated words, right? So you can use the actual value as an input, right? So this you can also pass as actual values, right? So actual values which are part of the training data set, actual values at t1, right? So that also you can pass as a input for the next timestamp, right? So it may happen that your model at the starting is not performing well, and it's kind of generating garbage values, so this y1 may not be the actual value that you are looking for, right? So that's why you don't want to use as a next step input. So what you can do is you can pass the actual values for that time step as an input for the t1 or the next timestamp, right? And generally what we do is we kind of mix and match these two approaches. Like we pick up a random value, and we check like if that random value is less than or not a teacher forcing value. So if for an example, like in the code we will also see, like I have used 0.5 as a teacher forcing ratio, so I will like use a random number generator, and I will check if the random number generator is less than 0.5 or not. If it is less than, then we will use the teacher forcing concept, otherwise we will use the actual output which is coming from the RNN, right? So with this, let's go and check how the code implementation looks like. So what we will implement is the Bahadanu's attention mechanism, and the reference which I am using is the official Pytorch document, and this is the actual implementation of the code, right? And if you see, in the last few videos I was mentioning that there is an alignment mechanism where we have the A00, and which takes the input of two inputs. One of them is like H0, which is coming from the encoder side, and another is the decoder side previous hidden state, right? So let me write it down as S0, and this is coming from the decoder previous timestamp input. And this A00 I have mentioned, this is nothing but a single layer neural network, right? Single layer neural network, and it will produce E00, and that E00 we will using a softmax we will convert to a capital E00, and using that we will calculate the context vector like C1 and the corresponding C2, C3 and C4, right? So here you can see this single layer neural network has been used here. So this previous hidden is coming from the decoder side, so you can call it as S0, and this is like H0, and both of them is passing through a single layer neural network. This is a fully connected layer they are mentioning here, and after that we are kind of adding these two things and applying tan H, and then we also have the alignment vector, right? So this output after the tonnage is being matrix multiplied, and we are getting the alignment score. And after that we are using a softmax, which will give you like E00. So this was actually E00, and this we will get as capital E00. And after that we will get the attention weights, and in the end we will multiply these things with the encoder output, which is H0, right? And we will get the context vector, right? So once we have the context vector, we can use it for the further processing of the decoder side, right? So this is the architecture we will follow in our code also, and we will try to implement that. Now let's go back to the code and see how the code is actually working. Data set and the same coding structure, so I will skip this part where we are like at first importing the libraries, then we are mentioning the file paths, then we are reading the files, and we are doing certain pre-processing like remove punctuation, converting the text to lowercase, removing the new line characters, then splitting individual words to tokens, and also getting this to this to dictionaries which are like index to word and what to index for English and Korean languages, right? So in case you haven't watched my previous video in this series, please go and check. I will also mention the link of that video in the description of this video. We'll jump to where we start implementing the models, right? So here the encoder RNN is same which we discussed in the previous video, and after that the new thing which we are adding here is this Bahadanu's attention, right? So here you can see the linear layers we have. So we have the linear layers, and then we also have another linear layer. So at first we are passing our query and keys. So these are nothing but the decoder previous hidden state and also the encoder hidden state that we are passing, and we are passing through it through the two linear layers, and after that we are applying the tonnage, and then we are kind of passing through another linear layer to get the scores, and using that scores we will apply the softmax to get the weights, and once we have the weights, that weights will be multiplied with the keys and we will get the context vector, right? And that will be return as an output from this class, right? The context and the weight vectors, right? So with that we will also implement the attention decoder RNN. So this is the decoder side is kind of changed here, which is not the same which we implemented in the previous video, and here we can see like we have our few of the regular stuff, like we have the embedding layer, then the attention layer. So this is my embedding layer, then we have the attention layer, then the RNN layer, and a fully connected linear layer which will kind of take the output of the RNN, and it will give back you the results for the dictionary size, right? So you can see like we are calculating the batch size, then we are creating a empty torch.empty data set, and we are filling this with the SOS token, right? So if you remember, like in the decoder side, the first layer takes out the start of sentence token, and it also takes the context vector, right? So this context vector will come from this side, and also we will pass as a SOS for the starting token, then it will kind of generate the output, and this output or the actual values for y2, right? Y2 actual, if I write it down, so whether we will send y1 or the y2 actual, that will be decided with a mechanism which I have discussed, that is teacher forcing, right? So with the help of teacher forcing, we will pass the actual values sometimes, the 50% of times, and also the decoder previous step output in some of the cases, right? So once we have that, we will loop through our sequence length, and we are doing a forward step here. So in the forward step, it's nothing but it's passing through the input to embedding layer, then it's getting the embedding output, and after that it's passing through the query and the encoded output through the attention layer, and we are getting back the context and the attention weights. In between we are just doing some manipulations at the shape, and we are getting the query here. That query being used here along with the encoder outputs, and we are passing through the attention layer to get the context and the attention vector. And after that we are concatenating our embedding output and the context vector to get the input which will be used at the RNN, and that we are passing here, and then we are getting the output and hidden after applying the RNN, and that we are passing as a parameter as an output from this forward step, right? So with that we will go back here, and after applying the forward step here we are getting the decoder output, decoder hidden, and the attention weights, right? And then this part is where we are applying the teacher forcing logic. So we are checking if the target tensor is not none. In case of it not none, we are using this as a decoder input, else we are using the predicted values from the previous step of the decoder, right? So this is where we are applying the without teacher forcing, right? And then we are calculating the decoder outputs, and in the end we are calculating also the attentions. So all this will be returned as an output from the decoder side, right? So once this implementations are done, then the regular steps are there, which I have also discussed in the previous video. So as you can see, I am initializing the teacher forcing ratio as 0.5. Then I am kind of using a random generator. I am checking if the value is less than teacher forcing ratio or not, and we are initializing this use teacher forcing variable, right? And when that variable has value, we are passing the target tensor, right? The actual value. So this is like the actual value we are passing here, and this is where we are applying the teacher forcing. And here if you see, so we are passing none, so it will kind of use the predicted values from the decoder, right? So with that we will implement the teacher forcing here, and after that we are calculating the loss, doing loss dot backward, optimizing each of the optimizers for encoder and decoder, and then we are kind of keep tracking of the loss, right? So after that, this is the training function where we are kind of looping through certain number of epochs, and we are keeping track of the losses, right? So here we can see that I am training my model with 10 number of epochs, and these are the losses after implementing like both the encoder and decoder with attention, right? So then we are kind of creating a make prediction function which will calculate the prediction, and this is how the comparison looks like, right? And after that we will also calculate the blue score, which is kind of 4.33 here, right? So I hope you got an understanding of this. So this is quite essential, this understanding of attention mechanism with RNN, and which kind of if you understand these things, your further journey to learning NLP or the attention mechanism which we generally used in case of like Hugging Face library, or I hope you like this one and you got an understanding of how the attention mechanism is working. And so yeah, that's all I have for this video. If you have found this content useful, please give a like and share this content with your friends and colleagues. Thank you. See you in the next video of this series.